Hey there. So last time I told you some stuff about one-point perspective and the very basics like the cone of vision and the horizon line and so on. And this time we're going to talk about two-point perspective. That is, when the object that we look on is now rotated along the horizontal axis. And so when we do that, the second vanishing point that was at infinity now is coming closer and closer. And I'm going to tell you how exactly and what kind of preparations you can do in order to draw accurate drawings in two-point perspective. So like last time, we have our frame that we draw in. It's maybe your paper, your canvas, or whatever resolution you decide on. Let's draw the lines that go right through the middle of this frame. And we can find the middle of the frame by just drawing lines from the diagonals, and we also add again our 60-degree cone of view. As I explained to you before, this frame does not have to touch the circle of view with all four corners. 2 or only 1 are enough, and then the radius of this circle here would be just the distance from the middle to the corner, which is the furthest away. In this case, for example, these two corners here. Now the question is, where are the vanishing points going to be on this horizon line? For that, we're going to look at our 3D model of this cube here again, and you can see how the vanishing points are moving in respect to the angle. And what you can also see is that these vanishing points are never within the picture at the same time. If there is one in the picture, then it's only one. And at 45 degrees, both of them are outside of the picture. And that is also true for our 60-degree cone of view. You would have to have at least 90 degrees in order to have both of the vanishing points in the picture at the same time. But we only have 60 degrees in order to minimize the distortion as much as possible. If you do the mistake and draw the vanishing points too close to each other, the objects are going to look very weird. Here, for example, the vanishing points got much closer, and this object in the middle looks a little bit weird, especially when we zoom in, doesn't it? Well, this object here is actually not a cube, but looks completely different. So you see, the distance between these vanishing points is very important. And I can also show you, no matter how you move your objects in a parallel way, the vanishing points for all of these objects are always going to be the same. They're always converging to the same point, no matter from where we're looking at, as you can see. And there's a very simple way to find these vanishing points, even in real life. And that is, for example, we have our cube again, and I'm placing it right here. And what you can do is you extend your arms and you make sure that your arms are parallel to the sides of this cube, like about so. So your arms are exactly at 90 degrees. And now when you're looking exactly where your arms are pointing at, then these are going to be the positions of the vanishing points of the cube. So we know now that the vanishing points are separated from each other at 90 degrees from the observer. And if your object does not have 90 degrees on the edges, like this cube here, but for example the object that I showed you before, the very distorted one, then the angle at which the vanishing points are apart would also change. This is why the vanishing points for the second object were much closer, because the angle was much smaller. Now, in order to find the two vanishing points, we have to at first again draw these two 30-degree angles. Same at here. 1, 2, 3, 4, 5, 6. Alright, and this is our station point. Or you can kind of imagine that the camera or the observer, whatever it is at exactly at this point. And so we can draw our 90-degree cone of view with exactly this point here. Now all we need to do is to draw a triangle that is going from the station point and is touching the horizon line, and right here has a 90-degree angle. And the angle from this middle line here would be how much we would rotate the object or ourselves. Now here, for example, I'm going to choose 40 degrees, alright? And therefore we have here 50 degrees. So again, the angle here is 40 degrees and here it's 50 degrees, and so in total we have 90. And these points on the horizon line are exactly our vanishing points. So vanishing point left and vanishing point right. We have the right side angle and the left side angle here. And now we can find our diagonal vanishing point, which is exactly at 45 degrees from both vanishing points. So right in between, right here, and the intersection with the horizon line is the diagonal vanishing point. And you can use this diagonal vanishing point to draw perfect squares. You just need to decide where you start from, connect it with the diagonal vanishing point, and then draw however big we want it to be, and then touch this line, and this is exactly where it needs to stop, and we can draw the perfect square on our flower like that. Now this is a quick and easy way to draw squares, however you don't exactly know how big it is. If we want to draw the same size but closer, then we don't know how big we need to draw, and therefore we need our measurement points. You can find these measurement points by simply drawing a curve from the vanishing points that is touching the station point and the intersection with this circle here, with this curve here, and the horizon line is going to be our measurement point. Here, measurement point 1, and the same for the other sides. We draw a circle, a curve right here, like so. And here we have our second measurement point. Let's make that a little clearer. Alright. And like last time, you can have your measurement scale at the bottom, which can be at any distance from the station point, of course. All we need to do is to decide where to place our object at, and then draw a line from the measurement point, whichever you want to at first, cross the point until you get to the measurement scale, and then we measure it. For example, I want to have 4 units. So 1, 2, 3, 4, it would be about here. I connect it again with the measurement point, and here was the point where we were at, and now I simply draw a horizontal line right here. I can count again. This would be like about 2.7 units, and I'm going to measure exactly the same right here and exactly the same right here, and again connect this point here with the other measurement point on the opposite side, and now we can draw the lines that are going to the vanishing point, and these are the positions we have to draw our vertical lines at, and the rest is very simple. Alright, and as I showed in my previous video, you can of course also measure different distances, like for example you take here twice the distance, connect it with the measurement point, and then draw the line. It's up to you. Now again, instead of drawing these circles and these angles and all the stuff, you can just quickly calculate it. And again, I prepared a nice little link for you. So when you click on the link, you get exactly this here. And what you need to do is just simply enter again the radius of the 60-degree cone of view, which is, as I explained to you before, just the distance between the middle of the cone of view and the corner of the frame you draw in, which is the furthest away. And R is the angle, the right-hand angle at which you rotate. So we have here about 710 pixels, and this angle here we need, and this angle we said before is 40 degrees. Now let's type in these values, 710, and then the angle 40 degrees. You don't have to insert a degree sign. And then you just simply go on solve. And there you go, you scroll down, all the way down until you get to the approximate values. These are the values you entered. L is the distance between the center of your cone of view and your left vanishing point, and R is this distance to the right vanishing point. D is the distance from the center of the cone of view to the diagonal vanishing point, and M1 to the first measurement point, and M2 to the second measurement point. Now let's check this. So we have at first our left vanishing point, which is about 1450. Yeah, close enough. Then the right one, 1020, also close enough, yeah. Then the diagonal vanishing point, about 100. The first measurement point, also close enough with 570. And the second one, 450. Alright. And now additionally, I also want to show you how to copy things, how to mirror things and repeat patterns. Here, for example, I just draw this wall here and I have this arbitrary shape here. It doesn't matter. And now what I want to do is I want to copy that and repeat it over and over again. And this you can do by at first finding the middle of it. This is the middle, and then you draw a line again to the vanishing point. Then you also extend these lines here. Then you take one of these corners and then go right through this point until you get through this line here. And this point is right where you need to draw the next line. And you can repeat this over and over again. And this is how you copy this shape here, how often you want to. Now another thing you can do is, again, you have the shape here, and let's say it's like a window or something like that, and you want to repeat it on your wall, but you have some distance in between them. And so let me extend these lines here again, and then we draw a line right where we want to have the next window. I didn't measure anything, it doesn't matter. And then draw this cross here so we see where the middle of this shape here would be, and then take one of these corners and draw a line right through this middle until we touch the bottom line or the top line, depends on which corner you choose, of course, and then draw the vertical line here. And what you did is you exactly mirrored this shape here on the other side, and so you have an exact copy of this window here at this position. You can again copy this shape too by drawing this middle line and then draw a line through this point here and draw the line down here, and this is now our real next window. And then you can repeat this pattern by taking one of these corners, going right through this point here, and then draw a line down here, and then mirror this window here as I showed you before. And you have again an exact copy of that mirror in the correct perspective. Alright, and to show you another example, I have here this shape, this arbitrary shape, it doesn't matter, like so. Alright, and I want to copy this shape to a different position, whatever position you want it to be. And you can do that by deciding at which point you want it to be. Let's say, for example, right here, and then we draw these lines here that are getting connected with the shape that we have, and then extend it like so. Alright. And this would be kind of like the path that this shape has to go in order to be there. Now, we use again the mirroring techniques that we learned before. We extend at first the lines here, make them cross, like so, and we have a projection already from this side of this shape here onto this one here. And now all I need to do is to mirror this shape over here, exactly how I showed you before. Go right through here and then draw the line here, and there we go. We copied this side of this shape here, of this cuboid here, right here, and you probably guessed it already. Now what we need to do is to do the same with the other side, and we can do that like so. We extend the lines here and here too, and now I have a projection of this side here of this cuboid onto this side here, and I want to shift it now over to this position. And again, we can do that with the mirroring technique, and this mirroring technique also works if this distance is actually shorter. All we need to do is again take this corner here and go right through the middle and then draw a line up. And now we have it. All we need to do is to connect the rest of the lines, and I'm going to make it thicker in order to make it more clear. And we successfully copied a shifted version, a moved version of the shape here to another position, and it is still pretty much the same shape. And this of course works in all 3 dimensions. You can also move some objects upwards or downwards, and also in every sort of perspective, in 1-point perspective, 2-point perspective, and also in 3-point perspective. Alright, that wasn't too complicated either. You can easily find those points very quickly, even quicker when you do the calculations, and especially when you just use the link that I provided to you and just quickly enter the angle and the radius. Alright, let's answer another question. This time, again from the same person, song name. I know already I asked. This question is related to the background music that I have in my videos. Well, there is no song name. I made the music myself actually. Of course not with real instruments other than the flute. The flute part is actually real, but the rest was done digitally. So yeah, this is also why there are no song titles in the description or anything, because, well, I made it myself. So question for you guys that would be very interesting to me. How did you learn about perspective at first, like at school or in your art book or whatever? As I mentioned at the beginning of my previous video, most books and websites and stuff like that I found that talked about perspective did it in this very inaccurate way, with just eyeballing and stuff like that. And well, maybe you had the chance to learn it in a more precise way, the more accurate way. I don't know. So please let me know in the comment section and ask me anything, preferably in a separate comment, and your question might appear in one of my videos. And of course, if you have some constructive feedback or requests from me, then please also let me know. Alright then, have fun drawing!